Good evening, everybody. Welcome to our latest Engineering at Scale talk. I am Brian O'Kelley, CEO of AppNexus, and I will be hosting this fireside chat with our esteemed guest, Dwight Merriman, CEO of 10gen, who's had a long history as perhaps...
Chairman now.
Oh, the chairman now, excuse me.
Recent change.
Important change, one we all aspire to. One of the most, accomplished senior technology leaders in New York. I mean, your history and the companies you've helped build have been the cornerstones, the keystones of New York technology. And so it's a real honor to have you here. And the basic format, for those of you who have not been to one of these talks before, is I ask Dwight embarrassing questions for about 45 minutes, and then we'll open it up. We've got a couple of mics, and would love to have questions from the audience. And the basic topic we cover is building at scale, building companies at scale, building technology at scale, building, especially from an engineering perspective, what it means to truly scale. Because that's the issue that most of us face in one or many forms as entrepreneurs and business people and leaders. So with that, perhaps you could walk us through sort of your experience, and I don't know your story before DoubleClick actually, how you came to all of this.
Okay, so hi everyone, I'm Dwight Merriman. I am chairman and co-founder of 10gen, which is the company behind MongoDB. We began the project and wrote the first lines of code on it, and maintained the root fork and so forth. MongoDB is, as some of you, half of you know, or 90% of you know perhaps, is an open source NoSQL database, NoSQL database. Very happy to be here. Thanks for the invitation. So just background, my background is software, CS undergrad, and then went and worked at a software company for 5 years, writing code and doing that kind of stuff. And then in 1995, with a partner, Kevin O'Connor, founded DoubleClick and was CTO at DoubleClick for 10 years, designed the original infrastructure there for Dart and all the tech there. So, which was definitely involved scale, especially back then when computers were 1,000 times slower than today. If you do the math, that's about right. It was that was interesting. I remember, when we started, there was just to give kind of context on that. There was on the scale and the time and what it was like then is when we started, there was no such thing as a load balancer. It did not exist, right? So we bought it was early on, right? It was like a year later. We bought I remember us buying a Cisco local director. Right, so we ordered one. I saw it existed, and I ordered one, and it came in. It was pretty expensive because it was from Cisco, at least at the time, we were a startup, and came in, and we, started to hook it up, and I looked at it, and I looked at the serial number, and the serial number was 7. I was like, okay. And actually, once we kind of tuned it in, dialed it in a bit, it worked really well. And it was quite useful. but that's kind of like what we were dealing with at the time. So that was just because the web was new. So at DoubleClick for 10 years went really well. We sold DoubleClick. When we sold it, the CEO of DoubleClick at that time was this guy named Kevin Ryan. So there's 2 Kevins that were at DoubleClick. And Kevin Ryan was there for like 95% of the time I was there. So he joined very early. At that point of that transaction, we were leaving after 10 years, and we were in New York, and we were like, okay, what do we want to do? And we were both interested in starting a new company. So we started working on some new ideas, and we had a couple of ideas, so we actually started a couple of things. And in the end, we started 5 companies since 2005. And 2 have been sold, Shopwiki and Panther. We sold a few years ago, and then the ones that remain are 10gen, which is what I spend 98% of my time on. Guilt Group, for which Kevin is chairman, but we're both help helped launch with others, and BusinessInsider.com, which we both helped start and launch with others. So those three are really the things that we work on the day, and we kind of, divide up the work. And so I work mainly on 10gen because it's very software and tech oriented, and kind of Kevin does a little bit of everything, including everything else, like guilt. So I'm at 10gen every day and working on MongoDB, which is going really well and just kind of exploding and really getting a lot of enterprise adoption right now.
That's amazing. I mean, the companies you've started are exactly the companies that are New York technology. And you're actually breaking a number of rules because we're not allowed to build real technology in New York. And it seems like you're trying to.
Yes, so most of the ones I mentioned are kind of more of a classic internet companies. And I think some of the ad tech companies like an AppNexus or DoubleClick are kind of internet infrastructure. So they're kind of a hybrid, right? So they actually are tech companies, but they're not the classic software Silicon Valley company, right? But 10gen is more like, it's an open source software company, but otherwise it's fundamentally it's a software company, and you just don't see a lot of those in New York unless we want to talk about Computer Associates or something. So
yeah, no, we don't want to talk about Computer Associates.
The other ones though are, yeah, so I think it is interesting though, and that's actually kind of motivating and exciting to me because the bigger we can make that, I think it's good for New York, I hope.
I think you're right. Now, I'm curious, when you started DoubleClick, where was your office at that time?
So we started it in Atlanta because I was working in Atlanta at DCA, which was doing telecommunications software. I was there for 5 years. And upon leaving, Kevin O'Connor and myself, we started brainstorming new ideas because we were both interested in doing a new company, doing something entrepreneurial. And in the end, the idea we liked best after brainstorming about 100 ideas was, or on a spreadsheet, was that idea of an advertising network. And then of course, at maturity at DoubleClick, it was really the ad tech business, sort of software as a service or whatever you want to call it, that was the real value. But in the beginning, it was building the whole network, both the sales component and the tech, kind of the whole thing was what we were trying to do. And I'm sorry, to finish your question, and very quickly, like in 6 months or so, we moved to New York because we wanted to be near the advertisers.
Yeah, and there's many fathers of DoubleClick. I mean, you meet people often who founded DoubleClick. And I know you're the real deal, but there's all the Poppy Tyson people.
Yeah, and we should talk about that since we are in the Poppy Tyson office right now.
I know.
Yeah, so I worked in this office where we're sitting right now in 1996. So the company Kevin and I started, there was also a group at Poppy Tyson, which was one of the first interactive agencies and part of Bozell, BJK&E ad agency, which was one of the big ad agencies. And they were right here, they were based here. And we met with them, and what they were doing at that time is they were selling ads on the internet, which was pretty progressive, right? They were selling ads on Netscape. I forget where else they were selling ads, but several
Alta
places.
Vista?
Not yet, it didn't exist yet. That was more like 98. But we did sell ads for them. So they were selling ads, they were doing repping, right? But they didn't have any technology or a network, but they had that vision actually. They had the same kind of conceptual vision we had, which was kind of make an internet advertising network. And kind of we had the pieces to make it work. We had a couple salespeople already. So we basically merged this group from within Poppy Tyson, kind of pulled it out, and then took our startup and we kind of merged those together. And then we moved to New York, moved into this office, and then the new company we called DoubleClick Inc. And we ran it, and with a bunch of good people from there also.
Yeah, it's kind of a small world to be back in this office.
Yeah, it's a little nicer now, the build out.
Yeah, well, that's really
It's a little dustier than maybe or something.
Yeah, Orange does amazing things.
But those things in the lobby, whatever those things are, they were here then.
Really?
Yes.
Wow, that's fancy.
I don't know what they are, like deer or something.
Yeah. I think they're taking them out now. They've run their course. Yeah, one of the things that's interesting about that, of course, is that if you look through the history of ad technology, it really started with you and with Poppy Tyson and with this decision. And the history is funny because it's not changed all that much in the last 20 years. The idea of agencies building ad networks, partnering with technology companies. I mean, I'm pretty sure we're on version 4.0 of that. Mm-hmm. So it's interesting that we haven't really evolved that much from the business model that was on your spreadsheet back in those days. But what I'm really interested in actually always is this idea of creating technology. So you're creating technology for, I remember the internet in 95, and I recall that there was no internet. I mean, we were talking about generally gray backgrounds and blue underlined links, and we're talking about a very early set of business models that weren't really defined.
In 95, there was, Yahoo.com existed, mm-hmm. and there was almost no ads on the internet, right? And back in that era, like InfoSeek had subscriptions as a search engine, for example. That's
great.
And there was a couple ads on the internet. There was a couple Zima ads, if you remember Zima, if you're old enough, on Yahoo. Other than that, there was no ads on the internet, pretty much as far as I could tell.
And so the ones that were there were hard-coded.
I'm sure they were, yeah.
Yeah.
But it was, so the kind of the way we got to the concept of an ad network and doing DoubleClick was we saw, to us as software guys, it was clear that the internet was going to be a huge trend, right? And we were looking at it and it was like, okay, this is really cool and useful, but what is the economic model underlying this? How are these sites going to get paid? How are they going to pay the bills and do all this content and other things? And there was no answer yet, right? And so our first thought was, well, maybe it's subscription, like InfoSeek thought, because at the time, AOL was pretty hot, right? And they had this walled garden of content, and basically you paid to access it. So that's kind of the obvious thing to project out at the time. So we looked at that a bit, and we looked at some ideas that involved subscriptions, like maybe Wall Street Journal still does that today, for example, on content. But then we started thinking, is there anything else, any other way it could work? Like, could advertising work? And there wasn't really any ads on the internet. So O'Connor, we didn't know anything about advertising, so he went to the library, got a book on advertising, and he read it. And then we concluded that we couldn't come up with any idea why advertising on the internet wouldn't work, right? Because we looked at all these other media, print, radio, broadcast television, cable, and it just seemed every time there was a new medium, it worked, right? So it was like, we can't figure out any reason why this wouldn't work. So, but there's a lot more. We felt there's a lot more granularity and fragmentation online, right? Because you got these, thousands or hundreds of thousands of websites, and then thousands of advertisers. If we just consider your classic advertisers, not what we have today with all the kind of local and advertisers where it gets up to millions, and they need to buy and sell ads, and how do you put that many conversations together? You need somebody in the middle, and that's why we thought you needed an ad network here, because there was a lot of granularity on the content side and the publishing side.
Yeah, well, and clearly that was the right answer. But what's really interesting from a technology perspective was just how little of that technology stack existed. I mean, even to do a simple transaction, I suspect there was quite a bit of glue required. I think about the things we take for granted today, like looking up an IP to figure out what city or country the user's coming from.
Yeah, so we wrote that ourselves because it didn't exist, right? The geolocation stuff and the geo-targeting and reporting. I wrote code for that in 1995 because it seemed to us that would be we were big on the concept of targeting from day one, so we wanted to be able to target on geography. So we had to write that ourselves, and now today it's available from a lot of vendors. So that's what we did, and I think eventually we used one of the third-party folks because they had a whole team on it. But But for years at DoubleClick, it was all homegrown, and it wasn't a not invented here thing. It was a never invented period thing, and so yeah, so that's a good example of kind of what the situation was. Like another one would be just that web browsers weren't quite baked yet. So I helped write like the web browser that we used in the ad server, and because we weren't totally happy with the other ones. They worked, but at scale they would have some issues, right? So at that time, so.
Yeah, but that's I think it's hard to remember is just how much we take for granted. You've talked about load balancers, you've talked about the underlying, web serving stack. I mean, this is really assembling from pieces that don't exist.
It's like async I/O for networking was just really starting to exist at that point in time.
But it's impressive to me. I mean, if you think about how, I'm not sure how many people in the crowd here are entrepreneurs, but often when you go to start a business, you take the best of what's out there, you assemble some pieces to prove your concept. And it seems to me that wasn't even possible at this time. You couldn't take, I suspect, you probably could have taken a off-the-shelf web server, an Apache type thing, and plugged in a CGI bin backend and physically served ads.
We did something akin to that, not CGI, but we did something like that day one, and then it started, kind of, the wheels started to wobble, and we had to do it over ourselves, et cetera.
But that's what's interesting to me, is because if you look at companies that hit scale, which is what the real purpose of this conversation is, the internet kind of hit scale at an extraordinary pace. I mean, from a couple of websites with ads in 95 to the .com explosion in 99 and 2000. I mean, volumes must have just been
it was
incredible.
exponential. Yeah.
And I feel like there's a line between companies that can keep up and can't. And the fact that you can even talk about implementing an asynchronous I/O stack on the operating systems of the day indicates a huge advantage, and a reason that DoubleClick could succeed is that, I'm speculating, you can handle the scale.
So we were kind of tying for first mover, so that's good. But in addition, there was a lot of competition, right? I think at one point we counted up that we had 17 competitors, right? So execution was incredibly important. So the way I look at entrepreneurship and startups is that there's really two things that can go wrong. One is that just your basic thesis doesn't work, like it doesn't hold up in the real world. So if you have an idea, it turns out in the real world it doesn't resonate, nobody likes it, nobody wants to buy it, et cetera, then no matter how good you execute, it doesn't matter, you're gonna die, right? And that's when you look at things like pivots, right? So then the other way things go wrong is execution, right? Do you execute well? Are you strong competitively? Do you hire well, which leads to good execution? Do you make operational mistakes, or it takes a little too long to get something done, or there's some kind of technology problem or scaling problem? We had plenty of scaling problems along the way for all of these, kind of partly for all of these reasons we were talking about, but we dealt with them. So it was interesting.
Yeah, looking back, I mean, there's plenty of people who have started or had started companies at that time, and the rate of change technologically was incredible. Mm-hmm. Again, partially fueled by that .com craze, where there was money thrown into the Ciscos, into the all the other companies. Things standardized very quickly. How did you realize that was happening? Because you built this business on a spreadsheet, not on a 20 years of online advertising experience, which would have been impossible. So at what point was it clear to you back in those days that this was going to hit a scale point? And how did you deal with that?
It was just on the fly. I don't think it was sort of a continuous, right? Because it was like, scale, and there's problems all along the way. It felt a little bit like you're in a car and you're rolling downhill, and so you're rolling downhill, so you're accelerating. And there's pieces of the car, if you go above a certain speed, they're gonna fall apart, like the wheels, right? So you gotta change them as you're rolling down the hill. and then you do before you get going that fast, and so everything's fine. And there's other pieces that need now going 100 miles an hour. Now you're going to be going 200, and something else is going to break, and then bad things will happen. So you got to get that fixed before you hit that. So it felt a little bit like that at the time.
Yeah, but that acceleration, I mean, DoubleClick, if I recall, was growing from a headcount perspective pretty quickly into the
Yeah, it was like
times.
doubling every year for many years, like 6 years or something.
Because it was what, 2,000 people at one point? I mean, it was
at peak, yeah. Well, actually, they may be more now, but that was the peak when I was there.
Yeah, they haven't fully taken over Google yet, so you can't claim on all.
No, but that would be a lot. It's not that big, yeah.
Yeah, but I think that's what's interesting. Is just that sense of, you call it, going downhill. And I think for many folks, when you're building a company, it feels like you're going uphill. So I've heard said.
Well, it's true. I mean, there's the scale problem only kicks in once it starts working, right? So I think the first challenge is just getting off the origin, like getting off zero, right? Getting when to notice, right? I think that's pretty hard too. But then once you do, then it's not very big, but maybe you have competitors, so there's sort of it's a competitive fight, and there's relative market share. And then at some point, if you're in a hot market, then it just kind of takes off, and then the scale thing comes in, the scaling challenges, and probably more scaling the business than the tech these days, although both are important.
Yeah, and it's interesting too, thinking about the kinds of people that make great founders, especially technical founders, because those who are very good at being agile and picking up the ideas and pivoting quickly to find the product market fit and getting to that next phase often don't have the experience to handle the scale and make smart decisions as companies hit the next phase. And so I look back at that time and I think about, we didn't know each other at that point, but I think that there's coming into the industry 5 years after that time, when I started in 2003, there was this legend of Dwight, the CTO, and handling these incredible scale barriers and sort of setting the bar for anyone who ever wanted to build ad technology. And so, your legend certainly haunted those of us who came behind. And so saying that computers were 1,000 times slower back then, I guess it gives you an
Well, in 03, they weren't. It was, they were only 10 times faster, maybe. Yeah.
Well, but it made things impossible. And one of the quotes that sort of inspired me when Matt Phillips and I came up with the idea for the Right Media Exchange, he said that he had mentioned it to you, and you said, no, that's technically impossible. And we wrote it above our computer screen, which is Dwight, because you were Dwight, says this is impossible. And it inspired us to do it anyway. And we cheated, of course, because...
And I remember having lunch with them, but I don't remember exactly, what did I say was impossible? Do you know?
I think it was the idea of computing every node of every possible combination of advertisers and publishers and real-time prediction or something like that. Like this idea of fully computing the exchange tree. He might have lied. He might have just said that to inspire me writing code.
Yeah, to get you to...
Because it was impossible.
You wanted, yeah.
So I fully acknowledge this may have been apocryphal.
So he told you, I said you couldn't do it.
Yeah.
And that worked really well, didn't it?
Yeah, exactly. It was inspiring.
Yeah, I'm not sure if that... I don't know. Maybe it's just a question. Maybe it was an emphasis thing or something. Maybe I said it was hard. It would be hard.
Well, I heard it was impossible. But I think that's... It's true. I mean, but I think that's actually what's interesting is there's this time element that you certainly have, having been, doing this for as long as you have, and even for me, looking at the increase in computing power, especially the move to cores as a vector for scalability. That there was a period there where every year things went faster without having to actually do a whole lot of architectural change.
Yeah, that's an interesting topic, because if you look at computers today, they're still getting faster, kind of with Moore's law, right? But clock speeds aren't going up. But what you're getting instead is that the transistor counts are still going up. So, but because the clock speeds aren't going up anymore, or at least not much, what they're doing is you just get a bunch of cores. So it's sort of, we're in a world where I can't give you a fast CPU core at any price, but I can give you 1,000 really cheaply. for a nickel each, right? But now you have a problem is which you have to split up your problem and be able to run it on 1,000 or 10,000 cores concurrently, right? So we're in a world now where parallelism and the technology stack is critical at all levels, right? You need it at every level, right? And we have it at a lot of, like at app servers, for example, I think there's pretty good parallelism, right? Just it kind of falls out there. At the network level, there's pretty good parallelism, like just because switches exist, right? Which, if you go back, we used to have hubs, right? So which weren't parallel really. So, but it's just amazing, like the at the center of the switch, kind of the aggregate throughput that's going through it, right? You got a 48 port gigabit switch, and you could have 48 gigabits per second going through it, or maybe even 96. But so, and not to mention the whole network or 10 gig or things like that. So that level, you got good parallelism. But there are some layers of the stack, if you will, of our systems where it's still challenging. And like one would be the data layer, right? Has been a really hard one to get that sort of horizontal scalability and parallelism at. And so, like with MongoDB, that's kind of what we're working on right now, or trying to work on. So,
yeah, and that's the really interesting point, because you're solving scale problems with MongoDB. I mean, that's a one of the many fundamental value propositions, I think, for any database, is to make it easier to deal with data at scale. Do you agree with that?
Yeah, and traditionally we haven't had that, right? Because databases scaled vertically, right? It's very hard to take a traditional database and make it scale horizontally, because there's two things that are really hard. One is distributed joins, because most traditional databases are relational. Distributed joins is a very hard problem, or perhaps an intractable problem, if you don't make any simplifying assumptions. So, if you say, I'm going to assume a star schema, and that we bulk load all the data at night, and it's read-only during the day, then it becomes tractable, right? So then, thus you have things like Greenplum and Vertica and so forth. But if you don't do that, so like more on the online side, the OLTP world, you don't see like products out there historically where you could, create a 1,000-node cluster that looks like on kind of commodity network, and it looks like one logical database. So that was the issue. And then another issue is just distributed transactions at that scale would be very hard, right? So, if we have a 1,000-node cluster and you want to do a transaction, and you want to do, in one transaction, mutate data, 600 pieces of data, and they're on 300 of the 1,000 servers, and you want that to be all isolated and atomic and all that good stuff, you can do it. It won't be fast, as far as I know, to do that. So that's a problem too. If we want to do it on 2 servers, it's fine. We just do 2-phase commit, and that'll work. That'll perform well on 2 servers. But at bigger scales, it's going to be a problem. So that's why, in my opinion, we haven't seen databases traditionally be able to do this thing that we do with other things like app servers, right? It's hard. So when we started working on MongoDB, 5.5 years ago or something, our approach to it was to say, boy, those are hard. Like, I'm not smart enough to do distributed joins on 1,000 server clusters, on commodity hardware servers and commodity networks without any simplifying assumptions, right? So I'm not going to do that. So what we did instead is we just said, well, let's not do joins, right? But then that means you're not relational, because if you don't have joins, you can't do relational database. And so we had to pick another data model. And then I think the area where we tried to innovate a little bit on then is sort of, okay, well, if you don't have joins, how do you actually create something that's useful and non-trivial, right? Because I think, I think lots of us can probably imagine how to build a 1,000-server distributed key value store that's persistent, right? And actually, that would be a very useful thing to have, right? But it won't cover all your use cases, right? So it might cover half, 50% max, unless you start writing kind of a database on top of it by writing extra layers. So we wanted to do something that had more functionality than that, right? So that would cover a good number of use cases without you having to reinvent the wheel. So we wanted to go deeper than just kind of get set by key some opaque value. We wanted to do something more like a traditional database where you have secondary indexes, ad hoc queries, sorting, at least a little bit of atomicity, ability of the database to look into the documents and reach into them and manipulate what's in there and that kind of stuff. And that's basically what we're doing and what we're up to.
Yeah, it's very, very cool. And as you know, I was playing around with it when we started AppNexus, trying to figure out if it could be our distributed key value store. And it was a slightly different problem set we were trying to solve.
Yeah, and the way I think of it is I think there's an engineering trade-off between sort of functionality and kind of ability to scale and speed, right? So if you think about it, like on the functionality dimension, and like relational databases, like an Oracle or something, they have a lot of functionality. You know, kitchen sink, if you will. Like they do a lot. Complex transactional semantics, lots of stuff. But they're only so fast, and they don't scale horizontally in general. And then if we go to the other end of the spectrum, like let's take memcached, for example. It scales pretty well. It's a key value store. It's not even persistent, right? So that's kind of the other point. But our observation is, if on that engineering trade-off, is that curve's not linear, is our thesis at least, is that there's a knee in that curve, right? That we can push over with the features pretty darn far, like say 80%, 75%, before you kind of drop off that cliff and fall down to a completely different level of scalability, horizontally or lack thereof, and speed and so forth. So that's what we're doing. So my opinion, you find like all of the NoSQL database products they're in a certain band of that graph between kind of medium-low to medium-high functionality. Nobody's at high, because if you go at high, according to my thesis, it's impossible to scale. And everyone has a little more than memcached because everyone has persistence. So I think of that kind of gradient there, kind of MongoDB is at the right end of it. It's kind of at the high feature end of the space. Like if you look at all the products, you could critique them and decide, one is better than another, it's whatever, has this feature, another one doesn't. But MongoDB is certainly at the high feature end of the spectrum. And I think that's also a reason why we still have more work to do to get it to kind of done, right, to maturity. So.
Yeah, it's exciting. I mean, I love watching the creation of new technology. And it's also interesting in context of this historical context, because you say what was once impossible, if you wait long enough by Moore's law, it will become possible because CPUs get faster. But not everything gets faster. A disk hasn't gotten faster at nearly the same space, but it's gotten bigger.
Yes.
The Moore's law of disk size has increased, but spindles don't go any faster.
And bytes per second sequentially too.
Yes.
Perhaps.
Well, but
not seek times.
Exactly.
Yeah.
So there's really interesting trade-offs that we have over this context of what's become easier in the, close to 20-year span we're talking about, and what hasn't. And the problems that we focus on solving change as well. So if I look at what AppNexus does in this idea of real-time bidding, the idea of real-time transactions between decisioning platforms doing real-time data lookups on both sides was probably impossible 10 years ago, just on a sheer computational speed basis. Yeah. And now it's fairly rote. We do it 50 billion times every day. It's interesting that some of these database problems are, I go back to like Berkeley DB, which has been around since forever. I mean, it's not like a new idea to have a NoSQL database. Fairly functional in the sense of...
You could argue IMS is one.
Yeah, well that's the point. Like, it's not a new problem that just suddenly was found, but the knee in the curve, I think, was something that many people discovered, that you could use a different approach to solve these problems. The question for me, though, is if you look at that in historical context, 30 plus years of SQL being the primary language that people use for databases. Not the only one, but the primary one. And now we have not just the NoSQL, memcached, Cassandra, Mongo. You also have the world of quote-unquote big data with Hadoop and MapReduce jobs. I mean, it feels like we're exploring this new frontier of thinking about data and maybe even thinking about computation in general.
Yeah.
And I wonder how much of that is sort of the impact of these Moore's law changes, where we take different parts of the compute stack for granted. Different things are hard, different network is free. I remember those difficult choices of, do you pay the extra for the switch?
Yeah.
When it mattered if you had switch. And now it's like, I haven't looked at the specs on a networking device in a long time.
Oh, wow, yeah.
Right? I mean, it's like, why would you care? Even the 10 gig upgrade isn't going to cost you the, $2,000 per port it would have cost you, back when I looked at these things. But that's sort of the interesting aspect of this, which is, if networking between servers is cheap, we don't have to worry about we can actually push things out into a distributed fashion. Disk is cheap, but also slow.
Yeah.
So if you think about that in the time you've been doing Mongo, it probably isn't a technological epoch in the sense of things have all changed. But if you look forward and you think about the path for database technologies, and we try to put our future hats on, having seen so much of this time frame, where does this go? What is the implication? Do many of these technologies go away because there's not enough room in that knee for so many different variants?
Well, I think there'll be a number of successful NoSQL products because it's going to be a big trend and a big space, and it's not a niche. It's conceptually, it's a pretty general purpose. I think one size fits all for databases is over, but you're going to have a handful of technologies. You don't want a dozen because you don't want to have to know a dozen, manage a dozen, master a dozen, right? But we've always had, like if we go back 10 years or 5 years, we already had two, right? So we were already out of one, beyond one size fits all, because you had an OLTP database and you had a data warehouse that were both relational, but completely different technologies. Like if you want to go kind of examples from a conservative company, it'd be Oracle and Teradata, right? Those are two different technologies. So I think what you're going to see happen now is that people are going to add another technology to their kind of database toolbox, which is a NoSQL database, and maybe they'll evaluate them all and pick one. You don't need to add 5. Maybe use Hadoop also. And the way I think about big data as a term is that big data is it's really not per se about big, that's a part of it, but it's really just these new technologies that are kind of disrupting the data world that have to do with data processing and databases, and it's really two buckets, NoSQL and Hadoop or type stuff. And currently those are about the same size in the level of activity. Like if you go on like Google Trends and you kind of add up all the NoSQL databases and you also type in Hadoop and the name of all the Hadoop companies and you add all that up, you'll get very similar kind of whatever they call it, interest or whatever on Google Trends. So, I think what you'll see over time is that the NoSQL stuff is very significant because Hadoop is a couple years older. So in a way, it's further along. And they're actually complementary, right? They're not competitive because the NoSQL databases are data stores. And Hadoop is really, to me, it's more about data processing, distributed computation, and ETL at scale, right? So those kind of fit together. I think you make a good point about how you got this Moore's Law thing happening, but then there's a couple pieces that aren't scaling with Moore's Law, like disk seek times. I think another one is just messaging latency or network latency, right? Because we used to have, you have one big server, like a mainframe or Sun E10000, and the intra-server latency is very low, right? And now, you're running Amazon EC2 and you have 1,000 servers or 1,000 VMs. The intra-server latency is very high. It's a lot higher. So that's actually interesting because it actually got worse, right? It got a lot worse. It got 100 times worse, right? Because now I have a latency between machines to send a message back and forth, and it's, a millisecond or a fraction or 0.3 of a millisecond or something like that, perhaps on like a commodity Ethernet, good commodity Ethernet, like with Cisco switches and things like that on the LAN. But before, we were in one machine, and it was much lower, obviously. So that's actually when it's gotten worse. The seek times at least didn't get worse; they just didn't get better. Now, the magnitude of the problem with these random access IOs on the disk has gotten worse, though, because the relative speed has completely fell off a cliff, right? Because if we go back 10 or 15 years, the disk seek times were the same order of magnitude, like 8 milliseconds. They might be twice as fast now, but they were the same order of magnitude. And everything else is, 100 or 1,000 times faster or 100,000 times more bytes per disk. So it's just, now it's like, it's almost comical, like how low those numbers are, right? But fortunately on that one, we have solid state disk now. And so I'm always telling people, use solid state disk a lot. I think it's essential. And use spinning disks for certain things, backups. You're going to use spinning disk for backup, right? It doesn't make any sense to use a solid state disk for that. But if you're doing random I/O, kind of online, real time, during the day, use solid state disk. Use, the high-end products are good, but they're great actually, but they're just expensive. But I also find good results with like the commodity SATA stuff, SSDs. And I'm always telling people with MongoDB, use SSDs, and it's just the performance profile of the whole thing changes radically. And then once you're kind of in that mindset, then I tell people, do everything in real time, don't do batch. You will need to do batch sometimes, but I'm saying nowadays to people, default to real time, which is the opposite of conventional best practices. If we kind of go back in time, talk to any CIO from 15 years ago, you default to batch because batch is very efficient, right? Real time is less efficient, especially if you can't do random I/O fast. But now if you have SSDs, you can do it pretty fast, and we have more RAM and things like that too. So I think like if you're a CIO at a Fortune 500 company, if I were like at Procter & Gamble or something, I would be telling the IT team, default to real time. You can do batch, but you need to make an argument that it won't work as real time.
It's actually a good point you make about SSDs.
Because like at DoubleClick, we did a lot of batch because we had no choice.
Yeah.
There was a lot of reports we crunched every night.
And when we started Right Media, one of our key competitive advantages was we built the whole thing to do real-time streaming processing. So we could do live reporting because DoubleClick couldn't.
And you were right on that cusp and early a little, but
exactly.
At that point in time where it's conceivable.
Yeah, exactly. That was like the competitive advantage. But it's interesting about SSDs because we looked at doing SSD for server-side data storage at Right Media, and it was a specialty product you could only get from one vendor, and it was like incredibly expensive, like $1 million for a big, huge refrigerator full of what was probably custom silicon. And then even at the start of AppNexus, 5 or 6 years later, I recall building out our first stack of SSDs, and it was pretty expensive. Like it was a competitive advantage that we could afford SSDs and others couldn't.
Right.
And now every laptop ships with them, and if you even have to think about it, you're probably doing something fundamentally wrong.
Yeah.
That's a 10-year period.
But I find that, especially when I deal with really big companies, that they're not quite there yet. They're not using them that heavily. I mean, so you guys, tell me about AppNexus. Is it all SSDs or what?
I don't think so. I think so. When you think about like the Hadoop and big data world versus the more real time, either NoSQL or other Memcached type things. I mean, that's that side of the world for us. Everything real time is on SSD. But the quote unquote big data part of this, I don't think we're using SSD for.
Well, so Hadoop, like if you're talking about Hadoop?
Yeah.
Yeah. So Hadoop is sequential I/O. So it makes sense to me to use spinning disk for Hadoop, for MapReduce.
I completely agree.
Because it was specifically designed to perform well in batch jobs, running on classical hardware.
Well, that's why it's funny you're saying
and
real
it's
time
all
versus
sequential.
batch.
Yeah.
Right.
So Hadoop is batch.
Exactly. The world's gone to the source. I think we should try to recharacterize the new big data movement to the batch data movement. All those big data meetups, let's just call them batch data meetups, right? We can say batch is back. I mean, CIO magazine, we can do a cover story, the two of us. Look, batch is back, yo, right? Hadoop this will be great. We're going to be famous. These insights, you didn't pay for this today, but we have brought you insights.
And if you think about real time, there's kind of the tech side of the real time, but then there's also sort of the just product speccing side. So it's sort of like imagine someone's on your website and they do something, right? So the question is, 30 seconds later, when they're on a different page, can you personalize it based on the data that activity they did 30 seconds earlier. Because if every night you do a job and you update all your predictive scores for everyone, their propensities for everything, so that it's then the next day it's personalized for them, it's like it's too late, right? Because I needed it 10 seconds, 20, 30 seconds later. As they're clicking through the site, I want to use that information because in my experience, like with stuff like that, the newest information is the most valuable information, right? It's like if you knew I was interested in golf a year ago, that's good, but if you found out something about me 5 minutes ago, like I'm planning a vacation, that's more useful just because the value of the data kind of decays over time.
You sound like someone from online advertising when you talk like that. I find it very compelling. But I mean, I'm in that business exactly. We're in the real-time predictive targeting business, so in that way, absolutely. You say 30 seconds, and I think that's an eternity. That's 500,000 ads of latency. If it's one person clicking 500,000 times in 30 seconds, that's fraud, just to be completely clear. So I would like to open this up to anyone else who would like to jump in and ask questions of Dwight. We have a mic right over here. So while you ponder your questions, I'll keep going, but please just pop up to the mic if you have a question. I was curious about this move to chairman and just how great it is not to have to be the CEO.
It's pretty good, but it's only good if the CEO is good, the new CEO, and if that person does not annoy you. So that's
you don't have to say on stage how you feel about that.
Well, it's actually going great. So the new CEO at 10gen is Max Shearson, and he's been with the company for a while as president. So if we go back in time, I was CEO, and from the beginning, and then we hired Max, and when we hired Max, I was still CEO, but then we gave him the title president, and what I did was I had him report to me, and everyone report to him. Right, so it was kind of halfway towards the current situation, and that worked out great. And he does a great job, and we get along really well, and we're very aligned. So it's only because of that it works. So then at some point, a few months ago, we made him CEO and me chairman because. When we started the company, I was coding a lot. Like I wrote a lot of the code in the early versions of MongoDB. And over time, as we get bigger, there's been a decay of that because the business stuff just pushes it down because there's just so much to do, right? So I think the catalyst for that was that I was kind of asymptotically approaching 0% coding time. So my goal was really just to get back to what I was doing 1 or 2 years before that, which was having a division of my time between not just coding, but just tech work, whether it's coding, design, product definition, and the business stuff, right? So it was never more than 50% tech for me, but at points it was 50%. Yeah, so on coding on the core product. So the goal there, that was my main goal, was to do that and get back working on the product some.
I think the godfather of that is Mark Andreessen, who says that the best and highest way to be a founder is to end up as the chairman and CTO of your company. So you're in good company.
Yeah. And I'm not CTO, but Elliot is, but I do a lot of tech work, so it's not completely different than that. And I guess also, I guess Mark Zuckerberg is not a pure model of that, but he does have kind of the whole non-product world of the company, I think under Sheryl Sandberg, is that right? So he's carved it out quite a bit that way, right?
Yeah, I think it's an interesting model. And you talk about people who proven they can scale a company through discontinuous growth, like Zuck did with Facebook. It's amazing watching the incredible growth. Yeah. Every single person on the planet is now on Facebook. Like as we speak, it's amazing. It's a true stat that I made up. That they were able to handle the scale, and they invented incredible technology on the fly during that process. And so it's interesting watching how even as the CEO, he was able to technically and then
Yeah.
through
Yeah, and I think the
engineering.
most amazing thing they did was the product. Like it's sort of like a product design, product management, product spec, all the features and the exact kind of look and feel of it to get people to want to use it. And it was like 100 or 1,000 decisions, sub-decisions there that kind of all added up. So that was amazing. And it's kind of one of the best examples of execution ever. Because, they were, it's sort of the opposite of DoubleClick. We started doing something that didn't exist, right? So, and maybe it'll work, maybe it won't. And there's a lot of companies, not all, but a lot of startups have done that. But they weren't doing that. Like social networks already existed, right? So they were just sort of iterating on the concept, trying to do a better job. And they did a much better job. So it really, execution was it's sort of the user experience and in the product and yeah, sure, the tech's got to work but yeah, I mean they just did a great job on that on the execution side. Or amazing job, perhaps so far.
Well, so far. With any company, you can only say so far.
Okay, so you said before that relational databases are not scalable enough, but Mark Zuckerberg kind of, in my opinion, cheating because I think Facebook doesn't do everything relational way. Did start with MySQL, and I think MySQL is still one of the main database models for Facebook.
As far as I know, it is, yeah.
What?
Keep going, yeah. I'm sorry.
What is the advantage of NoSQL databases like MongoDB, that's a document database, or a graph database, over MySQL if you can manually shard, which, yes, it's some extra work, but I know companies, Pinterest or Facebook, that do work with MySQL and manually shard the information. What's the advantage of NoSQL databases versus SQL databases on scalability?
Yeah, that's a good question. So I think there's two advantages. So it's because relational databases don't scale horizontally, I think it was a very common tactic or even almost the best practice when you had to do it yourself, do application layer partitioning of your data. So I'm sure you did it in the past at some point where at the data layer you had to split the data up and hit in things, right? And I know I did it in the past where I did basically manual sharding at the application layer. And you can do it. It's just a question of why are we not automating this as part of the question, right? So that's what we're trying to do, is to automate that. And one thing I've found in the past when I've done it is that it's very easy to get started, right? It's very easy to take your data and partition it into 11 buckets and have 11 shards. But now what happens when you want to add the 12th shard? It's a little hard then to kind of move the data around, and is that an online or an offline operation? So with things like MongoDB, we're trying to handle those kind of things and do that for you. And I'm guessing there's a medium-sized team at Facebook who works on that sharding stuff on top of MySQL. So I kind of feel like they're building a variant on MongoDB where the lower layers of it are MySQL. So that would, and it's like, do you want to write your own database is sort of the question. It's like, great, that's what we all used to do because we had no choice. But, we're trying to automate a lot of that and also make it an online operation, add more shards, and not an offline operation, and also just make it very seamless and easy. In addition, I think there's another reason to use it, which is because we have this different data model, this document-oriented JSON-style data model, I think it actually just, even on a single server, makes writing your app much easier, in my opinion. And you can write it faster because you have a data model that fits much better with the programming languages we use today. Kind of object relational impedance mismatch, quote unquote, kind of tends to go away. because JSON is really good at mapping from object-style data. I think it's very important to keep the code away from the data with the database. I think that's one of the big ideas in databases, so we're trying to do that. So in MongoDB, we're not storing methods or inheritance hierarchies like maybe an ODBMS would do, but we're storing the data of the objects. So that tends to be very clean, and then in addition, that sort of dynamic schema, or quote-unquote schemaless, which is a little imprecise, notion comes into play. It's very good at handling the types of data, the shapes of data we use today, which are different than before, right? If you're writing general ledger, a relational model is perfect, right? Because your real-world data is tabular, right? But if you have polymorphic data, semi-structured data, evolving structured data, right? So suppose you're an investment bank and you just have the fairly straightforward to articulate problem of just store all our current positions in the database in real time, right? Well, we've got equity positions, they have tickers and numbers of shares. We've got bond positions, they don't have numbers of shares, maybe. Maybe they just have notional values or something. And we also have positions that are derivatives, and mortgage-backed securities and all these things. So the positions we have, the securities we have positions in, it's polymorphic, right? We don't have, number of shares is not meaningful for all of our positions as a kind of a very basic thing. And then in addition, like on the derivative stuff, it's sort of like, well, okay, and this morning, one of our traders invented a new security, a new derivative, never existed before, has all these interesting new properties and all these call and put dates and things, and store that position. It didn't exist when you designed the system, right? So that's an example of a problem where I think the product lends itself naturally to it because it's very schema flexible, if you will. So it's sort of two reasons to use it. One is scale, and another is just that kind of developer velocity, perhaps. And that data, that sort of dynamic schema aspect also facilitates iterative development, agile development. If you want to do a release every day, it's sort of, do you do a schema DDL maintenance window every day? You don't want to do that. So that's sort of a good synergy too.
I think to put a point on that, the two things I think you said that are very specific to the SQL versus NoSQL debate is, it's not that you can't make SQL scale. Obviously you can in the Facebook case. It's just that I think your point before about the functionality versus scale trade-off, there's a lot of functionality in SQL that will not scale.
So yeah, I mean, you could write Facebook on Fortran, right? It's possible. But if you look at the,
I agree. I'm not saying you're wrong. I'm just saying that your points were very, very apt, which are, yes, you can make SQL scale. It's not that SQL doesn't scale. It's just that NoSQL is architected in a way that I think is inherently built for that
it's just sort of, how do you make it as little work as possible? Yeah, and another way I think about it, sort of same question, same problem, but different kind of frame of reference is, if you look at the technologies we use today to create systems and applications, the hardware and the software, everything has changed from 25 years ago, right? The network has changed, 25 years ago, probably SNA or something, or you were just running on a mainframe timeshare. The programming languages have changed, and they change often, like every 5 years probably, The software development methodologies have changed, right? It's not waterfall SDLC anymore. Everything has changed except the database, right? So 25 years ago, 20 years ago, you might have been using relational, still using it today. And that's actually a compliment to relational, to the theory and so forth, is just that it's the longest lived kind of IT technology, I think, period.
Well, I'm still coding in C, so I think I have you on that.
And that's just you. Everybody else is using C++.
Not at AppNexus. That's illegal.
But okay, fine. Okay, so I feel like at some point, theoretically, there should be a new technology for data layer that is something new, and an iteration on the technology and something fresh and useful and provides incremental value perhaps. And that's kind of what we're trying to do. And we think it's both due for it, and it is interesting though that technology lasted so long, because a lot of things haven't,
Yeah.
so.
It's true. It's amazing to think that it's been around as long as it has. It's so powerful.
I mean, it's
a core idea, but I agree with you.
Academically, it's as old as me, so that's really old.
Hi, Dwight. Brian, my name is Shaz. I come from the performance marketing, aka affiliate marketing world. And companies like Linkshare have, published reports that performance marketing is growing, yet Google just shut down their Google affiliate network. Just want to know if you guys have any thoughts on that and what your general thoughts are about performance marketing.
I will say that I am personally a big fan of performance marketing in general. It gets a bad rap. So I think what we'll see, AppNexus has a very large performance marketing business. Every day we serve about 1.5 billion CPC and CPA denominated ads, and we see that growing very, very quickly. I think it's gone through a phase where companies have been moving away from it, and I think they're going to move back very quickly. I mean, the idea of, all of search marketing was performance oriented, and ad.com built a, $1 billion ad network just on performance pretty much. Right Media started because a bunch of DoubleClick folks got pissed off at DoubleClick as an ad server didn't support performance very well. So in some ways, I think there's a very strong business case to be made for it, and I think you're right to say that it's getting less focused than it probably should.
Yeah, and I have an anecdote for you with that regard. Is the problem at DoubleClick was that we did it too early, which is I think around maybe 1997, we launched DoubleClick Direct, which was a CPA product.
I love that name.
And
anyone here who knows me knows I love the name of that product.
Right, so it was this network. It was all performance based. I think it was both CPA and CPC, and we were kind of optimizing on effective CPMs, kind of like AdWords does, in terms of what do you run, what do you ad these show. And that was way back then. And what happened I don't know what kind of effective CPMs you see today in performance marketing on kind of run the network inventory, but the eCPMs were about $1.
Wow.
Okay. And the conclusion at the time was that's way too low.
Yeah.
And so, because in part, it was such a hot time where internet advertising was taking off, you could go sell branded advertising on a CPM basis and you'd be getting $10, $20, so the $1, it's like $1, and this isn't search inventory or anything. This is more like AdSense, right?
Yeah.
So we stopped doing it, and
that's where Right Media came from.
Yeah.
There's a very quick point where $1 was a lot.
Right.
We're still in the days of $1 being a lot.
Well, it's fine. Yeah, I mean, if it costs a penny, what's wrong with $1? So yeah. So,
Exactly.
but the problem was actually that there was another buyer wanted to buy the same inventory for 10 at that moment, right? So, but that was the world. It was immature, right? It was just kind of fledgling, and a couple of years later, it's like, oh yeah, that would be good, But that's what happened.
That's so funny. Yeah, it'd be fun just to sit around and shoot the bull about all of the ebbs and flows. My favorite story on that is Boomerang, which was the DoubleClick retargeting product, won the Advertising Product of the Year award in 2006 or 7. See, we're laughing. No one else is.
And it was launched in the 90s, like
Yes.
in 99 or something.
The point being, everything is new again. There will be some amazing business, which will be like the new performance marketing business, and Google will acquire it for like $800 million and call it, the Google Affiliate Network. And the old will be new again. And we'll laugh again, and everyone will stare at us because we've been around doing this too long. And on that note, thank you all so much for coming.
Thanks.
Dwight, thank you very much. And